Hey guys, welcome to part 3 of the AQA to Summer 2017, Paper 2H. So here we're kicking off with question 21, and we should finish the paper in this video. Okay, so question 21, solve 5x squared equals 10x plus 4. So this is a quadratic equation. We know it's quadratic because we have an x squared term. So to solve these, we first of all need everything to be on the same side together. So we're going to take away the 10x and take away the 4, and then we've got 5x squared minus 10x minus 4 equals 0. Now, there's a bit of a clue here, given that we're on the calculator paper, and the question says to us, give our answer to 2 decimal places. That tells us we have to use the quadratic formula, which is this attractive looking guy up in the top right. So here our A is 5, B is minus 10, and C is minus 4. So if we plug these into the formula, we get x is equal to, or minus b, minus 10 is positive 10, plus or minus square root of minus 10 squared is 100. Now we've got minus 4 times 5, which is 20, times minus 4, which is going to give us positive 80, and that is all divided by 2 times a, so 2 times 5 is 10. So we've got x is equal to 10 plus or minus the square root of 180 all over 10. So our two solutions are x equals 10 plus root 180 all over 10, and x equals 10 minus root 180 all over 10. Now if we whack each of those into the calculator, we are going to get to 2 decimal places, 2.34 and minus 0.34. Jobs are good. Okay, question 22, so it's a proportion question. So a ball dropped vertically falls d meters in t seconds. D is directly proportional to the square of t. So that's the first important part. D is directly proportional to the square of t. So from that, we can write down D is proportional to t squared, and thus D is equal to k times t squared. So that is our proportion and our formula. Now we're told the ball drops 45 meters in the first 3 seconds. So next we can use that to work out the value of k. So D is 45 when t equals 3. If we substitute those values in, we get 45 is equal to k times 3 squared, which is 9. So if we divide by 9, we get k equals 45 divided by 9 is 5. So what we've got now, we've got the exact formula linking D and t. So d is 5t squared. Okay, so now we have the information we need to finish the question. Just be very careful here about what it's actually asking. It's asking us how far does the ball fall in the next 7 seconds. So how far does it fall from the point it's at after 3 seconds and then to 7 seconds later. So what we want to do here is find the distance after 10 seconds and then take away the distance after 3 seconds. So if t equals 10, then d is equal to 5 times 10 squared, so 500. So after 10 seconds, the ball has fallen 500 meters. To find how far it's fallen in the 7 seconds that we're interested in, we're going to do 500, so the distance after 10 seconds, minus 45, which is the distance after 3 seconds. So that will give us 455 meters. Jobs are good. And okay, question 23. So here we have some vector fun. So we've got this triangle with points A, B, C and D. The question asks us, is BCD a straight line? We must show our working. So if BCD is a straight line, then that means the two sections of it, so BC and CD, are parallel. If they're not parallel, then it's going to be a line, something like that, or two lines joined together. If they are parallel though, then it's one continuous straight line. So what we need to do is work out the vectors B to C and C to D, and see if one of them is a multiple of the other. So, for example, what I mean by that, say we had some vector A plus B, and then we had another vector, let's just say 5A plus 5B. These guys are parallel. I know this because I can write this second vector in the form 5 lots of A plus B. So that's a multiple of the first vector, A plus B. Therefore, those vectors are parallel. So we need to see if we get a similar situation for B to C and C to D. Okay, so first of all, B to C, well, to get from B to C, we're going to go positively along this vector, but then negatively along this vector. So, B to C is 5A minus 2B, and then minus 3A minus B. So if we simplify that a little bit, we've got B to C is equal to 2A minus 3B. Okay, so now we need to work out the vector C to D. Okay, then for C to D, we're going to go positively along this vector, and then positively along this vector. So C to D is going to be 3A add 3A, which is 6A, and then B minus 9B, which is minus 8B. So now that we've got these two vectors, we can see, or we can answer the question. We can now tell if they are parallel or not. Let's try and multiply BC so that we get 6a in it as well. And let's see if the B component is the same. So to turn 2a into 6a, we're going to multiply BC by 3. That's going to give us 6a minus 9b. Now that is not the same as C to D. C to D has a minus 8b. 3bc has a minus 9b. They're not the same. The lines aren't parallel. So the answer is no. Okay, question 24. So here we have a lovely histogram question. Everybody loves histograms. I used to hate them. So, 48 students completed some homework. The histogram shows information about the times it took them. Very interesting stuff. Then we're asked to work out an estimate for the interquartile range. We must show our working. So, first of all, an interquartile range is the range of the middle 50% of our data. So our 75th percentile bit of data and our 25th percentile piece of data. So what we need to do first of all is work out which number student is our lower quartile and which number student is our lower quartile. So to work out the lower quartile, we find 25% of 48, which is 12, and our upper quartile is 75% of 48. So 75% of 48 is 36. So what we need to do now, in our histogram, we need to track down an estimate for the time taken by the 12th person and an estimate for the time taken by the 36th person. Okay, so let's go in from the left first of all on this histogram to find an estimate for the location of the 12th person. So what we need to do is work out the frequency represented by each bar. So frequency in a histogram is given by the area of the rectangles. So for example, this first bar has an interval width of 5 and a frequency density of 1.6. So if we do 5 times 1.6, we get 8. So 8 people are represented by this first bar. In the second bar, we've got an interval width of 10, and we've got a frequency density of 0.8. So if we do 10 times 0.8, that's going to give us 8. So again, there's 8 people represented in this second bar. Now, 8 plus 8 is 16. So our 12th person, our lower quartile, is inside of that second bar. So what we need to work out is whereabouts is he or she. So the first bar contains 8 people. The second bar contains 8 people. To get from 8 to 12, we need to add on 4. So what we're going to do is split this second bar in half. And if we do that, if we draw a line down, that takes us down to 10 minutes. So our lower quartile, the time of the lower quartile is 10 minutes. So now we're going to do the same, in from the right, to find where our dwarfed person in from the right is, and roughly what their time was. Okay, so this last bar on the right has an interval width of 20 and a frequency density of 1. So 20 people are represented by that last bar. Now that means our upper quartile person is inside of this bar. Now then, because we have an interval length of 20 and there are 20 people inside of this bar, that means every one little square along the bottom is or represents one person. So if we got up to 45 people, what's 45 take away 12? It's 33. So the upper quartile person, as an estimate, is going to have taken 33 minutes. So then, the estimate for our interquartile range is upper 33, take away lower, so 33, take away 10, it's 23 minutes. Jobs are good. Okay, question 25. Now this is really the last big one of this paper, thank God. So this is a big question. So basically we've got a logo here. It's made up of two congruent triangles and a sector of a circle. Now we want to show that to two significant figures, the area of this logo is 510 centimeters squared. So it's a big question. Let me just walk you through the plan. So we can work out the area of the triangles using trigonometry, because we know an angle and the two side lengths coming out of them. Each triangle is exactly the same. So if we work out the area of one, multiply it by 2, that's the triangle's done. To work out the area of the sector though, we're going to need to work out the third length of the triangles to get the radius of the circle. Once we've got the radius of the circle, we can then work out the area of the sector. So let's get cracking. Okay, so first of all then, the area of a triangle using trigonometry. Let's completely ignore the fact this is called A, and let's in fact call it C. And then we can call the side lengths A and B. So now it's hopefully in familiar form for the formula. So the formula for area with trigonometry, area is 1/2 AB sine C. So basically if you know an angle and you know the two sides coming out of it, multiply the two sides by sine of the angle and then half it. So if we plonk our numbers in here, we would get 1/2 times 26 times 15 times sine 38. But what we can do though, because we've got two congruent triangles, is not worry about the 1/2, and then that will give us the area of both triangles. So if you just put in 15 times 26 times sine 38, hopefully you will get 240.1 centimeters squared. So let's make a note of that. The area of the triangles is 240.1 centimeters squared. Okay, so now we need to play with the cosine rule to work out the missing length of the circle, so the radius. Okay, so we're going to have to use the cosine rule here because we're in a non-right angled triangle and we don't have a matching pair of side and angle. If we did, we could use the cosine rule and we'd all be a lot happier. but we haven't. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos of a. So this time the angle is labelled nicely for us, capital A. So that means this side down here is little a, and then 26 and 15, doesn't matter which one we call B and C. So if we substitute our numbers in, we are going to get, let's go down here where we have more room, a squared equals 26 squared add 15 squared minus 2 times 26 times 15 cos of 38. So if we put that into our calculators, we get a squared is 286.4. Then if we square root that, we get a is equal to 16.9 centimetres if we go to one decimal place. So that now tells us the radius of the circle, or the sector if you like, is 16.9 centimetres. So now we need to work out the area of the sector, add it to the area of the triangles, and then pat ourselves on the back for getting the right answer. Okay, so to work out the area of a sector, we first of all need to know what fraction of the circle we have. So angles around a point add up to 360. So in a normal circle at the centre, there's 360 degrees. Here we've got 108 3/60ths, which simplifies to 3/10. So if we then work out the area of the circle, we then want to find 3/10 of it. So remember the formula for the area of a circle: area is pi times the radius squared. So the area of the sector is going to be 3/10 times pi times 16.9 squared. Chuck that into our calculators and we get 269.2 centimetres squared. So we finally have our two areas to add together. We've got the area of our triangles and now the area of our sector. So 240 add 240.1. So if we add those together, we're going to get 509.3 centimetres squared. Now if we do that to two significant figures as they want it, the second sig figure is the naught, so it's got a 9 after it, so it rounds to 510 centimetres squared. Thank God that's that question over. I cannot believe that's only worth 5 marks. It's pretty stingy, but job's a good one. Okay, question 26, something a lot lighter here, 2 multiple choice questions to do with invariant points. So an invariant point is a point that doesn't move when being put through a transformation. So here we got this quadrilateral with vertexes A, B, C and D. We're told the quadrilateral is enlarged with a scale factor of 1/3, centre point B. And then we're asked for which vertex is invariant. So if we're enlarging this shape with reference to point B, then it means if we're enlarging with a scale factor of 1/3, what it means is every other point, A, C, and D, gets moved closer to point B. In fact, everything gets 1/3 of the distance away from B. The only point that doesn't move is B itself. So B is the invariant vertex. So B is our answer to part A. So part B is a very similar question, except this time we're dealing with a reflection. So with a reflection, any point that doesn't lie on the line of reflection will move to the other side of that line. So here, again, we're looking for an invariant point when this shape is reflected in the line y equals x. So what we're looking for here is one of these points lies on the line y equals x. So we're looking for a set of coordinates that where the x value is the same as the y value, and that's the point P. P has coordinates 1, 1, so if y equals x, then 1 does indeed equal 1. So point P is not going to move at all, so it's invariant. P is our answer. Okay, question 27, we've made it to the final question. So here we've got h of x is equal to the cube root of x for all values of x. On the diagram below, we want to sketch the graph of h minus 1 of x for values of x from -2 to +2. So h minus 1 of x means the inverse h function. So here it's quite simple to get the inverse function. What is the exact opposite of cube rooting something? It's to cube something. So h inverse of x is x cubed. So what we need to do now is just get ourselves some coordinates for h inverse x for values of x from -2 up to +2. So if we get ourselves a little table of our x values on top, our y values down here, then we got x -2, and -2 cubed is -8. Then when x is -1, -1 cubed is -1. When x is 0, 0 cubed is 0. When x is 1, 1 cubed is 1. And then when x is +2, we get y is +8. So we want to plot these points on the graph below and join them up with a curve to get something that looks like this. Okay, and then 27b, for all values of x, f of x is equal to sine of x, and t of x is equal to x plus 90. Now we're asked to draw the graph of the composite function f t of x. So f t of x is going to be sine of x plus 90. So what's going to happen here? Let's just take a rough little look at the graph of sine of x. So sine of x looks like that. This point over here is 360. This point in the middle is 180. This over here is 0. The peak happens at 90 degrees. Then the trough happens at 270. the maximum value is 1 and the minimum value is -1. So that's our graph of sine of x. What sine of x plus 90 is going to look like? It's a shift 90 degrees to the left. So everything happens 90 degrees faster. So the peak is actually going to happen over here on the x-axis. Then it's going to hit, on the y-axis. Then it's going to hit the x-axis, not at 180 degrees, but at 90 degrees. Then the trough is going to be at 180 degrees, for example. So it's actually going to give us the cos graph. So the sketch of this is going to look something like this. And there we go, guys, paper done. Hope to see you for paper 3.